In every era, there is a need, a spark, an instinct that brings us together to imagine and to innovate. This hasn't changed. What's possible has. We create technology that makes our world better. Ideas that move us, empower, and connect us. But great ideas cannot thrive alone. They need to be shared, challenged, refined. Through our insight and collective curiosity, we advance and grow. New solutions, new directions, new answers. We do that here, together. This is the age of connected intelligence. Welcome to the IQ era.
Hello, hello. I hope that you're ready for a great panel on robotics, effectively, robots among us. Are we ready for embodied AI? My name is Julie Tegland. I'm a Global Vice Chair of EY on our global alliances. And I'm really thrilled to host a panel today in just a few minutes to talk about embodied AI and where are we on this journey. I want to be a little bit provocative. I have three theses that we're going to work to today to really talk about. My first one is, I really believe that we're at a unique moment in the AI journey where it's no longer distant or abstract. It's really becoming embodied, physical. It's increasingly present in the home, in the factory, and the workplace. I think we all agree with that. But here are the three truths. Today, software is ready, but hardware is not. And in fact, globally, outside of China, our hardware has really suffered from a chronic underinvestment in the last years. And that's needed to effectively bring AI to life. Today, we see tremendous advanced capabilities in humanoids on a very individual level. Fantastic capabilities, almost extraordinary. But scaling that into hundreds and maybe even thousands of coordinated robots is completely unthinkable today. They cannot be orchestrated by a single data layer. That's a completely different challenge. It requires a merger, effectively, of hardware, software, connectivity, and mission-critical orchestration that we do not have. So while we are accelerating in AI, my third truth is that we're accelerating effectively separate from that journey with humanoid, bringing it together to really embody those worlds, the systems, the robotic platforms, and effectively next-gen connectivity. All of this, of course, is underlined by the issues that we're faced in the supply chain, the reality of data fragmentation, and the question of whether the world can even produce hardware fast enough. I don't want to paint a depressing picture, but I want you to understand the challenges of where we are and how these challenges are going to be addressed as we go forward. How we can manage really bringing hardware and software together, how we can manage designing that orchestration layer, and how we really drive investment into the hardware to make sure that we can capitalize on the opportunity. There is no possible way that I could have this conversation or discussion alone, and I'd like to bring my panelists to the stage as we call them out. I have Dr. William Shi from AGI in Europe. I have Kevin Schatzkammer from Microsoft. And I have Nakul Duggal from Qualcomm Technologies. who are going to join me on the stage for a great conversation. And I'm going to kick this off by asking each of them to introduce themselves.
Yeah.
William, can I start with you? Give a little bit of background.
Yeah.
Talk to us about Agibot.
Yeah. Agibot is a startup company from Shanghai. We are 1,000 employees, just have 1,000 employees. We have different products, like the full-size humanoid robotics and the half-size. We have some also the embodied dogs. Yeah. So they are all, we call that embodied humanoid robotics. Yeah.
I love that. And they're already live and working with you.
Yeah.
We're going to come back to you to talk about those challenges that I talked about, how we get over those challenges.
Yeah, sure.
Kevin, how about you?
Sure. So Kevin Schatzkamer, I think everyone's heard of Microsoft. It's maybe a little bit easier to introduce as a company. And if I think about where we're at in our focus area, right, it's really on thinking about how can we play a role in helping to build and accelerate humans, robots, systems, and agents in the AI space, all collaborating and working together in a productive way. And that's everything from how do we think about the evolution of foundation models away from text and data into foundation action models, all the way into some of the challenges that you raise in terms of how do we think about this as a system, as an entire platform, and think about end-to-end orchestration of fleets of things moving together in real world.
I think that's where the magic is. And in the individual level, there's lots of good stuff, but getting that coordinated to a fleet is where we really see scale. So how about you, Nakul? Talk to us about your background, Qualcomm, 6G.
So Qualcomm has been focused on edge AI now for a number of years. And this transition towards embodied AI, where you're moving from classical AI to large language models, which are mostly human-centric, to physical AI, where you're actually dealing with physical space and you're training robots to be able to do something that large language models were clearly not designed for, is really a very interesting inflection point, because you have to think about what is the current state of the art in terms of hardware, what can you lean on the foundational model research that's been done over the last decade or so, but then what do you have to do different? Because this is actually a very interesting time. I would love to talk about your comments on hardware, because I feel like catching up to the hardware problem statement is actually not all that complex. I think it really comes down to how do you deal with the physical world in the context of AI? And that, to me, is a fascinating space. I'm looking forward to the conversation.
But I'm looking forward to that, because I thought to kick this off, I wanted us to be provocative. There's so much out there in terms of myths, and I'd like to ground us a little bit in reality. William, I'm going to start with you, because you're dealing in the field of robots. We know it's rapidly moving from the lab into real-world environments. From your vantage point as a leading robotic innovator, where are they being deployed today, and how are we enabling their transition into our everyday lives?
The humanoid robotics is on the very early stage. Yeah, so you can see everywhere on the video that the robot start to moving, do some very simple tasks. Yeah, but from our industry expert, yeah, we think it's still on the very early stage. Yeah, because there's a lot of challenges that we are facing together. For example, the lack of data. Yeah, we don't have enough data to fill in the robotics to running. Yeah, so every training is made by the person, by the manipulation, and we find also the other way, yeah, to feeding also data, by the virtualization, yeah, by using also maybe a Microsoft platform, yeah, and the Qualcomm chipset capability, yeah. So the robotics, is also the ecosystem, yeah. So today I think the most interesting scenario now is ready for the commercialized is, for example, the performing, the dancing on the stage, yeah, to giving you some entertainment, yeah, the value. Yeah, I think this is just a start. Yeah, we are looking for also the other scenarios like how we can help the university and the colleges to set up the lessons. Yeah, as you know, if we estimate in the future when there is more and more robotics, working in the society, and we need more engineering services, and we need more people, can help to, repair the robotics. Yeah, so that will create a lot of jobs as well. Yeah.
That's interesting. It's interesting. So I love where you've gone with the real world and getting them out there. And you see use cases moving from being helpful to providing entertainment.
Yeah.
And much more coming in terms of fleets of robots. But you also see a whole industry coming in terms of repairing, upskilling them, and training them, and the need for more engineers.
Yeah, that's it. Yeah, because today the number of the robotics is very limited. Yeah, the whole world last year, 2025, is only 13,000 robotics that we built together in the world, including us, including Tesla, Optimus, including Figure AI. Yeah. So today we are ranked #1 today. Which means more than 5,000 robotics are created by AGI bot. But that's still a small number. I think maybe in 10 years later, the production capacity will reach more than 2 million, 3 million. Elon Musk said that can be reach 10 million. Yeah, but from our estimation, maybe 2 or 3 million. Yeah, even 2 or 3 million. How many engineers that we need to serve back to this industry? I think this is a good number. Yeah.
And can I ask you, just following on that thread?
Yeah, sure.
What's holding us back? From expanding. What do you see the issue being holding us back from expanding from Musk's 10 to your 2 to 3? Is it the number of engineers?
I think
the data?
The first is the data today. Yeah, the first is the data. The second is production capacity. Yeah, and the third one is the engineer.
Engineering.
Yeah,
skills.
engineer. Yeah, so most of the engineers that we recruit today, they have the background of the automotive industry, or maybe software engineering. Yeah, so you see the embodied robotics. They have the hardware. They have also the software. Yeah, so the hardware is mainly from the engineer today that we can find from automotive industry. Yeah, but the software is also another challenge for the AI. Yeah.
Okay, so you've listed more challenges, but huge potential going from 13,000 to 2 to 3 million in the next 5 years.
Yeah.
Kevin, I want to come to you because while he's on the hardware side, also software, but a lot of hardware, you're definitely on the orchestration and creating a platform side. How do we design those intelligent systems that are going to allow us to capture the data that William's talking about? How do we get this intelligent at scale and create fleets? Let's be honest, 2 to 3 million, they're not going to all work individually. You're going to have them assembling, working in teams, tasking together. How does that going to work?
Yeah, I think, look, it's an area that we're actually really early in. When I think about problem number one is the latency challenge that you have to solve, and edge computing and edge inferencing is the first path to that, right? The data is still not clean. There's still more work to do in terms of getting the data ready. And if, everyone's been around this show, we're talking about AI quite a bit. We're talking about agents quite a bit. And when we think about agents in the software world and orchestrating them together, we're still really early in defining even that, right? And the expectations of those agents collaborating and making decisions together and de-risking decisions for humans and even being orchestrated to complete tasks together, right, by calling APIs. And now you extrapolate that, like you said, into the real world, right? The spatial data looks different. It's much more robust, right? Which means that processing power needs to increase. The decisions that are being made are not just software decisions or human decisions. It's actually decisions that are being actioned in the physical world. And then lastly, right, it's not APIs that we're interacting with in order to be able to solicit action. It's actuators, right, in the physical world. So when we start to put those pieces together, I think we have some of the fundamental building blocks in place, right? Mobile edge computing is there, edge GPUs are there. We know how to connect infrastructure that allows us to connect, to coordinate, to inference, to command, and to collect data. Now, how do we accelerate the processing time of that to be able to orchestrate, to your point, these fleets? A lot of learning to still do, and I think that's the journey most of us are on and working towards.
So Kevin, can I just follow up on just 2 points?
Of course.
If William's talking about a journey of, say 3 to 5 years to get to those 2 to 3 million bots, do you feel that's the same? We're on a journey, we're going to accelerate, we're going to start to orchestrate, doing, I'm going to say virtual agents first before they're really acting in the physical world?
I think we'll collect a great deal of learnings from virtual agents in the software world in terms of how you build distributed systems to work together in this way. I think a lot of those learnings will apply, but real world, spatial, and the risks that the physical world implies and the uncertainty that the physical world implies are going to be learning as the hardware comes online. We're going to be iterative together.
Yeah, I agree.
Do you see that's 3 to 5?
It sounds like we don't have a choice.
We move together, I think.
I like that, the move together. I like where we're going. Okay, 3 to 5 years, and it gives me a little bit of confidence we're going to manage the orchestration. You'll collect more data. The hardware will get better as we go.
Yeah, I mean, look, software is funny, right? The last 8 weeks just alone and what we've done with software development agents and what they're capable of with GitHub Copilot and Cloud Code, what we've seen with OpenClaw, a technology for distributed systems and how they work together. Like, it's moving at a pace that I don't know that we've ever seen before, right? So I feel optimistic that give us 3 years and, it's very fuzzy in terms of what that future might look like because the next 8 weeks are fuzzy enough in software.
I like that, but huge amounts of potential, and I agree. The speed's moving at paces we've never seen before. It might go much faster, which is what Musk is betting on, right? The only way he gets to 10 is if the software goes faster, we can iron out the kinks.
Yeah.
But hardware and software is not alone. Mukul, I'm going to come to you. You think about the age of robotics, and you think about what's it going to take to really be successful. What do you think the prerequisites are to really get humanoids driving ecosystems at scale? What does that deployment look like? And I would be wrong if I didn't ask you, is 6G kind of a must-have, or do you think that's a nice-to-have?
Yeah. So I think if you think about robotics over the last 20 years or so, one major problem that robotics has solved is mobility. You can find robots that can move, and that isn't really a problem that is considered a problem anymore. Then if you think about perception, with self-driving, perception was a problem that is now solved. You have vision language models, and you can look at something and you can translate it into the English language or really any language. So the big scale up in my mind in robotics for them to be used very widely is dexterity. You have to be able to actually manipulate objects, and that is where you get the unlock in terms of being able to have very wide applications. And that to me is where robots become really useful, because you have to be able to not just report, not just perceive, not just move, carry something from A to B, but actually take the action of being able to perform a task that otherwise a human performs. There are so many examples you can think of, and I'm sure all of us have those in mind. It could be very simple things, but you have to be able to do them with a very high level of predictability. To do that, you have to connect the brain and the nervous system together. It's not just a brain problem. There is actually a nervous system problem, which is not a problem that we've had to deal with so far, because self-driving cars don't have a nervous system. They just have eyes, and they have motion, and you stop or you start. Coding agents perform
tasks.
Code.
Yeah.
But this concept of being able to actually perform a task, and it could be a very simple task, but you have to be able to perform it in a predictable way, a safe way, a reliable way, repeatedly, get to 9 nines reliability, or 6 nines reliability. That has a combination of being able to connect the hardware, that is the robot itself, whether it's actuation, it's a hand, it's an arm, and the brain connected to the nervous system, which goes back to William's point about data.
Yeah.
We've never really had to go deal with data like this. So in my mind, this is a really interesting time, because the problem to solve is how do you get access to the data, and there are gradients of complexity in that data. Performing the task of sitting at the edge of a warehouse sorting packages versus picking strawberries versus working in a high precision machine factory all require very different levels of precision, which is tied to the hardware that you actually need. So to me, if you solve that, that's the big unlock. The rest of it, in my mind, in the scheme of things, the rate at which technology is moving are not problems that we are going to spend a lot of time thinking about, which includes the connectivity piece. Of course, connectivity will keep improving. You'll be able to do better. Of course, you can orchestrate data better. I mean, to Kevin's point about how quickly coding agents are solving these problems. So to me, it's a question of what is the new problem that we have not encountered yet, which requires you to deal with new hardware, software complexity, which to me is the fascinating part. I think that's why this is such an interesting space.
So I love that point. I love your comment on dexterity, because I agree. I also agree on the data layer, and would bring William back in. How are you accumulating and solving the data challenge based on the bots that you're already building? How are you orchestrating that data layer? Where is this going?
Yeah. So as I explained, that the data will be very important to improve, the technology from the embodied robotics. But we, differentiate also the different kind of data. Yeah. Some of data we think it's not, sensitive that we would like to share. For example, how do the tasks in the kitchen, in the bedroom, in the living room. Yeah. And then we're training, for the robotics to serving the coffee, cappuccino, espresso. Yeah, so this kind of data will be very useful for all human in the world. I think that can be useful everywhere. They are not sensitive. Yeah, but some of data they could be sensitive. Depends also on the different countries' policy. For example, for the industry. Yeah, so one day when the robotics ready, working in the industry to serve, to do some tasks, and in some very sensitive industry, and that can be very, sensitive data. And then I think the most important is how we can, set up the policy. Yeah, for example, in Europe, everybody knows the GDPR, protect personal data. I think this is very important. Yeah, so when in the future, when the robotics is ready, working in the sensitive industry, I think this is another story. But today, we still need a bit time, yeah, to train the robot to work in the industry. But it's the scenario will be very large, yeah. So the first of all, I think the robot today is ready on the stage to do some performing, yeah, live streaming, yeah. Tomorrow can be maybe working, in family or maybe in the hospital, and then working in the industry. Yeah, we have different stage. Yeah, but the biggest challenge today is it's not yet how we protect the data, but first how we create as much as possible the data. Yeah. So today the challenge is that we don't have enough the data. Yeah. So I think we need to solve first this problem, and then we solve another problem to how to protect the data. Yeah.
I agree with that, and if you allow, I'll tell just a little story. We were working on a project in a shipbuilding industry to create humanoids to do a dangerous job.
Yeah.
Just a welding job.
Yeah.
And you would think that's not so hard but training the robots was really a huge task that required substantial amount of time.
That's it.
Even to the point that you're raising, Mukul, about the dexterity, even getting their balance right when they're lifting, things that you would think are, simple, are very, very difficult from the data side. Being able to manage their balance, what happens in different temperatures, what happens in different wind condition, what happens in getting that predictability and that level of consistency based on the level of data. It takes time to accumulate the data and then to train the models.
That's it. That's it. Yeah. Even without the dangerous situation, but we still working on some the bad condition. Yeah. For example, extremely cold. Yeah. Wet and with some gas, dangerous. Yeah. So we start working with our embodied dogs. Yeah, who can have some inspection, to do some surveillance. Of course, we need also the second development, to install some sensor on the top of the, our dogs.
On the top of the bots to be able to know, where they are, what type of environment they're in.
Yeah. That's it. Yeah.
It's super interesting, but gives real perspective for where we're going.
Yeah, very interesting industry. Yeah.
Well,
Kevin.
what I love about this conversation is that, first off, we've done a good job of identifying a number of areas where there's opportunity and continued development. I think you painted a little bit of a doom and gloom scenario to kind of kick us off.
Get us going.
Let's get us going.
But we should be more positive towards the end.
But I think if we step back, and I'm going to kind of pivot to some positivity, right? There's so many problems that we have solved.
Oh, yeah,
right?
yeah,
Like
definitely.
in the autonomous driving space, we've solved this perceive, predict, act, right? And that loop has been solved,
Yeah.
right? We've solved how do we build distributed software systems that can act across multi-agents or in process of solving, right? We've actually learned how to incorporate highly probabilistic technologies and capabilities into software systems where the entire system is not deterministic. Like all of these start to come into play. But the risks of not getting it right when we're living in the physical world are very different. And the controlled environments in which we expect to encounter generally don't exist.
No, it's true. The lab environments.
Right? You made
It's not how it's
a
going to
very
be.
simple example, like pour a cup of coffee for me. I can guarantee you my kitchen does not look the same 2 days in a row.
No, and we're not in the same location. You're not,
Yeah.
very, very different.
You know, if you think about self-driving and where the industry was 10 years ago, and now Waymo doing robotaxis that you can actually hail, right? I think that kind of speaks to how many different technologies have to come together to be able to get to that level of sophistication. I feel like in robotics, there is actually a lot of prior art because robots have been working in automation environments in a safe way for a number of years.
Yeah, already think of automotive.
That's not that. I mean, that's not a new thing for robots to actually be working in manufacturing environments. And there is a lot of know-how within the automotive industry, the robot industry, in terms of how do you make sure that this is done safely. It really just comes down to, in my mind, you have to find a problem that you need to scale. You can't be solving something that will get you to the next 10,000 robots that you have to. So you have to pick something that has to be from a problem that it is solving. It really has to make a big impact in terms of productivity, in terms of removing humans from jobs that you don't want a human to go to.
The high
So it
risk
has to be,
pieces. Yeah.
well, or it could just be it's not a very productive thing for a human to do. It's high labor. It doesn't make you efficient after you finish an 8-hour job. Because when you look for high risk, the number of jobs are actually not all that large.
Smile.
So it has to be dexterity, but it has to be the same kind of job where the skill that you're training the robot for is transferable. So if you find something that is transferable, and that's why to me, if you think about dexterity, it goes to, is it coarse dexterity or fine dexterity? If you start with coarse dexterity and that skill is portable, and you bring a lot of the other assets that have actually been pulled together over a number of years, that gives you that unlock. And so, for us internally, what it comes down to is focus on things that will allow you to be able to solve a problem safely, where the task that you're solving has portability. And once you go focus on that, and you have to trace it back, you have to have the hardware in place, you have to have things that can scale. It should be cross-region, could be cross-industry. It should not be varying degrees of complexity. You have to narrow the level
simple.
of complexity, and then you get the unlock.
I think that's really interesting. It tells me that the agriculture business could be very interesting for where you go for scale, effectively requiring a certain level of dexterity, if I'm honest, a certain level of precision, but very similar environments, in fact, that's scalable across geography.
And impact, right? Like 1% improvement in commercial crop yields is huge.
I think you were making the point earlier about how mobility comes into play, because if the environment that you are in is not stable, so like if you bring in agriculture or if you bring in an industrial automation environment, if the location that you are in is not stable, that actually has an impact to the efficiency of the robot. If you're in a warehouse, if you're on a factory floor.
Yeah, cement floor, it's different.
Like picking the problem statement environment has a lot to do with how quickly will you find the unlock as well. Right? So when we think about this, we really think about pattern matching around how do you reduce the number of variables that you have to worry about when you're trying to make something perfect. And once you get there, then you can introduce another new variable as opposed to focusing on a very broad set of verticals, because that doesn't allow you to control the variables.
So go as narrow as possible, start with the least complex, and add variable by variable. I think that's a good recipe. I'm going to come back to Kevin to ask him about cloud architecture and ask, where are we on this world and how does that fit into everything that we're talking about in terms of, we've mentioned the data layer, we've mentioned the complexity of trying to isolate the field. How does cloud architecture fit in?
Yeah, I think, look, we have so many great pieces in place, right? I think an end-to-end infrastructure control plane to the edge is fantastic, and that's in place. I think we have good eventing technologies, MQTT being in place. We have great pre-processing, perceiving capabilities, even offline operation when we have system outages and connectivity issues. Like, that world has come together. I think deterministic multi-agent loops, we're probably early on the software side at really thinking through, I think cross-site scheduling, even the identity, right? What is the identity in the policy that applies to physical activation is a really early space, right?
It's an interesting space, though.
It's a really interesting space. I mean, we obviously know how to identify physical humans, right? We're now assigning and ascribing an identity to software agents. This next layer of, where are they receiving their agency and delegation of authority from, and where is their permissioning, and what is their scope of action, and when do they stop?
Yeah.
Right?
Or do they
All
stop?
of that is still really early kind of thinking through. And this, I think it really, when we think about it and bring it all together, and when I hear what everyone says, it's how do we take hardware and robots and infrastructure and software and telemetry and get it to behave as a single safe
unit
system.
Yeah. Yeah.
Like a single system that's safe, and then extrapolate it and say it now needs to work across entire fleets that are acting together, not just at the individual level. There's a really fun problem statement in here.
Absolutely.
Yeah, but what I feel is we're getting closer to solving that. I have to ask William, because of something you said. Are you naming your dogs? Have you given them an identity, your bot dogs? And do you see that happening? And I'm saying it in a playful way, but it really links to the identity issue that Kevin spoke about.
Yeah, identification I think is very important for the robotics. We create the platform for the robotics. We don't want the robotics looks like the same. Yeah, they should have the different outlook. They should have different even the personality. Yeah, so there's one platform that we create called the Link Craft and the Link Soul. Yeah, so that you can create your own robotics. Yeah, and that will help also to increase the interaction between the human and the robotics. Yeah.
It's super interesting, especially when you talk about giving them different personalities and then the guardrails, Kevin, that you spoke about from a security perspective.
Exactly. We are very happy, to be in the ecosystem, because embodied robotics is not just one company or maybe one industry. It should be involved with everybody to move together. Yeah.
I really like that. Mukul, that's where I would ask you. You talk about, if William talks about ecosystems, what do you think it takes to bring all of this together? And we've been actually having an ecosystem conversation today already.
I mean, it's a fascinating question because there are so many dimensions to this. There is the dimension that you started off with in your earlier remarks around hardware. And can you even build the hardware? Is the hardware available to be able to build in any part of the world? So that's an aspect of the ecosystem that is very unique to robotics. Like if I think about a humanoid and all of the various components that you need to have in place, there are industries that have that capability, but in terms of being able to build something that looks like a humanoid, has to be able to function with that level of reliability. Is that ecosystem there? No, I think that's a gap. I think that certainly, especially in the West, doesn't exist in my mind.
I agree. That's why I made those comments in the beginning to be a bit provocative. I share your view, though. I think it's not going to be a problem to catch up, but I do feel that that's underinvested in today. I just feel it's a giant gap.
Completely agree. And I think it has a lot to do with practicing the problem statement. You really have to be building this, putting it into real implementations, because this is essentially not a software problem statement alone. This is actually an industrial automation problem statement. That has a lot of hardware and software that has to come. So you have to deal with the physics of the problem statement. And so if you have to get down to the manufacturing complexity, the quality of the sensors, the quality of the actuators. So that's kind of one area. I think the other area, which I think we've talked about from an ecosystem perspective, is data. There is the problem statement of you have to define the semi-structured or the unstructured data set, the database that you need to be thinking about in terms of what does it mean to have a 3D data set for converting a task into its components of what the motion is, because it's physics. There's a tactile aspect to it. There is a force feedback aspect to it. There is a temperature aspect to it, to certain examples.
World.
So that's a brand new problem statement. Like that isn't something that you think about when you look at image or video. It actually has to do with the physicality of what it is that you're doing. So that's a new area. And then it comes down to, can you get down to some kind of a standard way of doing it? So can you break the problem statements down into, in an industrial automation environment, what is the coarse or fine or precision variable that you add to it, versus if you're in a warehouse environment where you're just moving packages around, what do you need? That is why I feel like there is a very tight correlation between the hardware and the problem. Once you can correlate those two, you can come up with a data set that you can say, okay, I can now collect this data and train on it, and then I can eventually even optimize the environment that I want to deploy in the future to be aligned around this, as opposed to the environment is always unstructured. So the ecosystem question to me is really interesting because it's a multi-stage question. You have to spend some time thinking about how you solve problems today. Once you get a solve, then you think about in the future, what does not need to be a variable? What can I actually make as a constant so next time I can actually scale up faster? Right. So, we'll be here for another few hours if we get going on this. But to me, I think the ecosystem piece is actually the fascinating piece. The other piece is it's very global, right?
It's very global.
Like this is not a problem statement that is tied to any geography, any vertical. It is actually a problem statement all of us can relate to. So
I love a point that you made in that we need to get into real world as quickly as possible, that living in a lab environment and a controlled environment is not going to give us the learnings and teachings at the accelerated rate that we need. And I also think that that's a problem statement that we're addressing right now in AI systems as well, in terms of learning the proximity to stakeholder and use cases and how important it is to not think about these software systems in isolation of the use case, the environment, and the function in which they're expected to go and deliver. And I think, the behavioral change of how we build systems now as a result of some of the agentic work that's happening is also going to prove very valuable to what we use moving forward.
No, I totally agree. I think we're setting, a lot of the work that's going on now is going to set the foundation for what we do as we move forward. If there was, I know we have like 7 minutes left, if there's one piece in this whole puzzle that we could accelerate, what would your, pixie dust, what would your magic wand kind of accelerate? Which piece would you move on to make it, to make us go faster in this journey, to make the 3 million, maybe a 10 million bot, to help some of our economies where robots are actually incredibly needed quicker rather than later? What would you do, William?
It's hard to say. Maybe the robotics can, be supposed to be working in the education.
In education?
Education, yeah. Because as I said that we need a lot of engineer, and where this engineer come from? I think come from a university. Yeah, so it will be easy. Also, in terms of the, when the robotics started to, be implemented in the university, and we don't have, so many policy or maybe the data protection issue. Yeah, so it will be more open because the students, yeah, they can, learn on the robotics. It's like, 20 years ago. Yeah, so when we have, smartphone industry and maybe electronic car industry, yeah, so the student, they have a very good imagination. And I think every country has the, many, many good university. Yeah, I think they can work together. And the students, they are much more open, yeah, to talk each other.
I love this because you think back, if you would have said maybe in 2022, I'm going to gander a guess.
Yeah.
Top field for students to go to.
Yeah.
A lot of it was around IT coding.
Yeah.
And now we're shifting that actually dramatically. In a mere 4 years
AI.
later, we're
Yeah.
saying now go maybe towards robotics and engineering
Yeah.
as a base skill, as opposed to just the IT space.
Yeah.
Is that true?
I think so. Yeah, the technology evolved, quite quick. Yeah, so sometimes, we sometimes forget, what we should learn. Yeah, so if we look back, 10 years ago, what we learned is becoming, more and more useless. Yeah, so keep learning, I think, is very important. Yeah,
I like that.
Yeah.
And I think I love your accelerator being
Yeah.
education system, more engineering, more robotics.
Yeah.
Kevin, what's your accelerator?
Well, now I like he took such a good one. He gave such a good answer. It's hard. I guess if I think that we're in a 3-year time horizon to the quantity that
Yeah.
you called out, right? Manufacturing has to be coming online now, right? We have to be thinking about what is the assembly process and where's the manufacturing that's going to produce at that volume. And those don't happen overnight. Building the facilities and the capabilities to do that is also needs to be accelerated in parallel to how fast the software and hardware is iterating.
I love that. So start building in advance, see the use cases, and designing those production, which takes time. It's going to take time.
And belief, right? Because you're forward investing ahead of a business case, right? Which is typically the case in manufacturing, but there's been such small iterations of the dial in terms of where we've gone, right? Everything we've done in manufacturing has largely been thought of, how do we make things smaller? How do we make them more efficient? How do we make
Smarter,
them more powerful?
faster, yeah.
This is a disrupt.
Yeah, it's a complete different. So that almost makes manufacturing, if I can say, it turns manufacturing sexy again in terms of something completely new. We're not looking for the smaller, cheaper, faster. We're looking for something bold, something different. That's a completely new field in manufacturing, if you ask me. Completely new term. How about you, Mukul? What's your accelerator? What's your pick?
To me, I think the part that is new is physical AI, right? It's that physical part. Because if you think about how have we gotten to where we have with AI over the last 5 years, it's because over the last 20 years, we've been operating with the internet. We have enormous amounts of data that you can train on. You have video, you have images, you have language, and this is available at a global scale. And that is why LLMs have gotten so much better and now VLMs have gotten so much better in such a short period of time, because the compute capacity is there. You can train at massive scale, you have reams of data to train upon, and that has allowed model architectures to evolve very rapidly over the last 2 to 3 years. To me, the physical AI opportunity is massive, because if you think about applying AI to human automation, where there are lots of jobs that humans won't do, cannot do, the way demographics are going, population, etc. That's actually a real problem statement that every society faces. And yet, it's not something that the technology was available to be able to go solve. Now, I feel like, I'll just guess a number here. You have 75% of the technology that is needed. You still need that remaining 25%. So if I were to put all of my energy, it would be on that last 25%. And then you take everything else that's available, and then you actually get this scale multiplier effect. And I do feel like it's a complicated problem, which is why you have to partition it carefully. You need the actuators, you need the sensors, you need the ability to actually define what do you want to automate, and then get that data collected. And I feel like that actually will change the way you build factories, you build services businesses, you build hospitality businesses, you build healthcare facilities. All of that will change once you had that solution. So I feel like you have to focus on that solve, and then I think you can start to think about how verticals evolve.
I am interested that no one mentioned battery technology.
No, they didn't.
Where we feel we are in terms of the maturity of battery technology to keep pace.
To keep them going and to keep them not connected on a cable, to be honest.
There is battery, there is connectivity, there is chip technology, but I feel like there is enough resource available in the ecosystem today that if you had to go push really hard on that, you would be able to find solutions. I mean, there are constraints. I mean, there are physical constraints that exist there today, but I feel like if you find the sensor unlock, I think that really changes things.
I love this panel. I'm going to need your help to thank them in just a second, but I want to capture some of the few really bites of wisdom. Data is absolutely essential for where we go, and education, more engineers needed.
Yeah.
If I think, Kevin, I thought the piece of wisdom for you was think systemically, think in systems and how we manage that as a system. Mokala, I loved the dexterity, grounded in the physical, and really focus on the opportunity of AI to unlock that physical AI potential. I started off this panel with a super negative, there's 3 things, hardware's not there, chronic on-investment. I'm landing on a positive. The future is open, and it's going to change everything. With that, thank you very much for a great conversation.
Thank you, Julie. Thank you. Yeah, thank you.
It's great.
Yeah, thank
In
you.
the AI era, you can empower your people to work smarter and solve problems faster. Build deeper trust with customers through responsible AI use. And transform every part of your business to accelerate growth. You can with AI. You can with KPMG.